So today is the first day of the next unit. Still trigonometry is what we're diving into. And we are going to look at, these are three primary trig functions. We say sine, cosine, and tangent. And these are the secondary trig functions, and they have a relationship with each one that's across from it. So when we evaluate an angle and we determine the sine of it, we're just comparing two of the three sides of a triangle. So which two sides do we choose? We choose the opposite over the hypotenuse. We went over this before spring break, but we're going to use it again. Cosine, we're going to compare two of the three sides, specifically adjacent over hypotenuse, and tangent is opposite over adjacent. Now these secondary ones are just reciprocal. I don't like to say the word opposite because students assume then we change a sign. We're just going to take whatever the sine is and flip it. The secant is flipped from the cosine, and the cotangent is flipped from the tangent. We're going to start with the very first problem. Please draw yourself a right triangle, just like I have. Okay, so we are going to evaluate the angle that's been chosen here. We'll call this theta. And all we're going to do is we're going to follow directions. But before we can get started, we need to know all three sides of a triangle. So I know the two legs. Legs are always going to help create the 90-degree angle. The hypotenuse is the longest side. So on your paper, please write this down. You would have learned this in 8th and 9th grade, but it's possible you don't remember it. It's called the Pythagorean theorem. And we can use it to determine any side of a right triangle when you have two of the three sides. The A and the B are always the legs. So A can either be 3 or A in this case can be 5. Totally up to you. So 3 squared plus 5 squared equals, and we're going to call this length C, equals C squared. And so I want to figure out what is this longest side known as the hypotenuse. 3 squared, 3 times 3 is 9, 5 times 5 is 25, and 9 plus 25 is 34. Now what I want to make sure you write down is we're going to make a list of perfect squares. Please make sure to make this list. 1, 4, 9, and you're thinking, how is she getting these? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. You guys get the idea of this, right? It just keeps going. Well, how is that going to help us? You're going to grab your calculator right now, and we're going to see, can I break down the square root of 34? Because in order to isolate the C, opposite of squaring is square root. So C equals the square root of 34, but it's my job at this level to see, can I break that down? So everybody grab your calculator, please. And first we need to see, where does 34 land? 34 lands right here in between 25 and 36. So I'm going to test all the numbers moving backwards all the way to 1. 1 doesn't ever break anything down. So can everybody do me a favor? Take 34 and divide it by 25. If we don't get a nice whole number, I know 25 is not going to help me. It doesn't work. Now we're going to take 34 and divide it by 16. That doesn't work. 34 divided by 9 also does not work. And 34 divided by 4 does not work. I don't need to test 1 because dividing by 1 doesn't actually break anything down. So please go off to your triangle and write the square root of 34. When you get a nice pretty answer like the square root of 25, then we could just broke it down. Then we could just broke it down to 5. But we first see, can we break it down? In this case, we couldn't. Good question. Okay, you ready?
How do you know it was
That's a great question. How do I know whether to make, in this case, should A be 3 or should A be 5? It doesn't matter. You get the same answer in the end. Yep. Same answer. They're both on this side. You're just going to add those quantities after you square them. Good question. Okay, so your job now is simply to follow directions, and here are the directions. You're going to make a fraction. We're going to find out where this angle is, and we're going to determine what's opposite side of that angle and what's the hypotenuse of this triangle that contains this angle. So that's what we're going to do next. Okay, here's the angle. What length is opposite? Opposite is 5. And what is the hypotenuse? It is the square root of 34. Now we're going to come back to this later on. Mathematically it's not wrong, but it's not proper. We're going to come back to it later. Cosine. Cosine, we're just going to follow the directions. So here's cosine. Cosine says we're going to make a ratio, a fraction, and the top number is going to be adjacent to this angle. The bottom number is going to be the hypotenuse. Okay, so here's my angle. Adjacent is one of those words that kids are like, oh yeah, I know what it means, but a lot of students don't really know what does it mean. Adjacent means that it helps create the angle that we're focused on. So two sides create the angle. But the adjacent side can never be the longest side. So I need to actually cancel out the square root of 34, making this the adjacent side. 3 is the adjacent side for this angle. Maybe you even want to write ADJ here. 3 is the adjacent side for this angle.
Do you need the copies of the interest to look up because you said on your note that like you need it later. Okay.
Okay.
How do you know exactly which side is the adjacent?
Sure. So you're going to find the angle, and like I'm literally going to use my hands. Please don't talk right now. And so you agree that my two hands represent those sides that makes the angle, right? So one of these two sides is going to be the adjacent side. And we determine which one it is but it can never be the hypotenuse. So it was this side or this side, but it can never be the hypotenuse, which is the longest side. So it cancels out the square root of 34, leaving me only with 3.
So without the hypotenuse, we wouldn't know what we're looking at.
Right. So like if we like, let me just make this one up. Let's say if I said, what about this one down here? Okay. So let's say this angle, and I said, well, which side is the adjacent side? So I know that this length and this length help create that angle. Now, which one is adjacent? Well, it can never be the longest side, so it has to be adjacent to this would be 5. Does that make sense? Okay. So let's come back here. Cosine is adjacent over hypotenuse. Adjacent is 3. Hypotenuse is the square root of 34. Okay, let's go tangent next. Let's go tangent next. Tangent is opposite over adjacent. Opposite over adjacent. So from this angle, please don't. Opposite of this angle is 5, and adjacent is 3. So 5 over 3. Okay, now we're not going to use the word opposite here because the relationship is it's the word called reciprocal. And reciprocal means we're literally taking it and we're flipping the top and the bottom. So this is going to be the square root of 34 over 5. This is going to be the square root of 34 over 3, and this is going to be 3 over 5. Please go ahead and do that.
Can you repeat that?
Yep, give me 1 second, I'll do it for you. Yep. So these two have a relationship. Please don't talk. These two have a relationship. Once you find the sign, you're going to flip it. So the bottom goes to the top goes to the bottom.
Oh.
These two have a relationship. Bottom goes top goes to the bottom. Does that make sense?
Yeah.
Relationship, just flips it.
Like that's the same thing, we just flip it.
What'd you say?
It's like the same thing,
You just flip it, that's what you do. Yep.
Is that for every question?
That's for every single one. Sine and cosecant are always just flipped. Cosine and secant are always just flipped, every single time.
What about, like, does it have negative and positive?
So we're not going to get there yet, but later on we will. So his question is, do I need to worry about negatives or positives? Not just with a normal triangle right now. Not with it being on a coordinate plane. You had a question, Mello? Okay, so here's the next one. All of this is mathematically right, but once you get to this level of algebra 3-4, your final answer needs to be simplified, and it can't have a square root on the bottom. So does this have a square root on the bottom? Nope. Final answer. No square root on the bottom, no square root on the bottom, no square root on the bottom. Does anybody in here remember from like 3 weeks ago the shortcut to rewriting this in the equivalent way?
Yeah.
Somebody just said yeah. Okay, what do you think it is?
It's, you write the square root of 34.
Yep.
And then 5
Yep.
next to it. And the square root of 34 again. The bottom.
So close. So one thing. So what you're going to do is you're going to take this and you're going to throw it up top. So 5 square roots of 34, just like he said. Take the bottom and throw it up top. And then you're going to rewrite the number in the bottom now with no square root. So this one, take this one, throw it up top. So 3 square roots of 34, and then write 34 on the bottom with no square root.
Do we like Excel?
Oh, yeah. So what he's saying to me is, can you X these out? I mean, you can, but as long as you just circle what the final one is, we're good.
Do you always have to rewrite it that way?
You always have to rewrite it whenever you have a square root in the denominator. So these 4 I didn't have to worry about. Alan, shh. These 4 I didn't have to worry about because there's no square root in the denominator. These 2 had a square root in the denominator. So the very first thing we're going to do is we're going to figure out what is this length. So please follow along with me as you take notes. You will be allowed to use notes in anything you do, whether it's a quiz or homework. So here we go. We're going to write down a squared plus b squared equals c squared. These two sides of the right triangle are called the legs. They create the 90-degree angle. Make sure you're writing this down. So it doesn't matter which one is A or which one is B. Now when you write this down, you need to mimic what I'm doing. So I'm going to write down 5 squared and then 4 square roots of 3 squared. This is where there's lots of confusion. What does this mean? This means the base needs to be multiplied by itself twice, so I'm going to do that. This means the base needs to be multiplied by itself twice. How did I know to multiply it twice? That's what the square means. I know 5 times 5 is 25. I know 4 times 4 is 16. And I know the square root of 3 times the square root of 3. Well, when you have square roots, you can multiply them and keep it underneath. So 3 times 3 is 9. What is the square root of 9? The square root of 9 is, in fact, no, you don't divide it by 2, but that's a good guess.
Can you do that again?
Yeah. How did I get 3?
Yeah. No, the 16 and the 9.
Okay, so do you see how when I look at these 4 terms, do you see how these two numbers are alike because they don't have a square root? So 4 times 4 is 16. The square root of 3 times 3, they're alike. So 3 times 3 is the square root of 9. Okay, so now on your calculator, you're going to plug in exactly like I'm doing. We're going to take 25 plus 16 times 3. Okay, now in order to isolate the c, we're going to take the square root of both sides. And now, just like we did in the previous problem, I need to know, does the square root of 73 reduce? So I'm going to make that list, and you should have it already on your paper, of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81. So grab your calculator, please. I'm going to identify where 73 lands in this list. 73 is between 64 and 81, and I'm going to work backwards. I'm not going to go and use 1, but I'm going to go all the way down to 1. So please with me, take 73 and divide it by 64. If I don't get a nice number with no decimals, it means it doesn't work. 73 and divided by 49. Okay, I'm going to give you right now 15 seconds to go all the way down. Go, on your calculator. I tested them all, and I can see every single time I divided by a perfect square, I never got a nice answer. What does it mean? It means it can't be broken apart. So over here, please write the square root of 73. Turn to somebody next to you. Those groups that don't participate get to do 8 additional homework problems today. Are you ready? Look in your notes. What divided by what? I'm not asking for a number. I'm asking for what words do we use to describe the ratio of sign. An example, is it adjacent divided by opposite? What is it? Look into your notes. Turn to your partner. What is it? Those two groups are talking. What is it? It is opposite divided by hypotenuse. So let's look here. Let's first identify for this triangle. When we look at this angle, opposite is the easy one. So I'm going to put OPP over here. The longest side is across from, it's the diagonal side, and it's opposite of the 90 degrees. So this is the hypotenuse. And we only have one side left. It has to be the adjacent. Also, notice that my 2 fingers represent this angle created, and the longest side up here can't be adjacent. That means adjacent has to be 4 square roots of 3. So here we go. I've heard groups say sine is opposite divided by hypotenuse. That is perfect. So opposite of this angle is 5, and hypotenuse is the square root of 73.
How did you switch again? The adjacent and the opposite?
Say it to me again. What?
How did you switch again? The adjacent.
Why is adjacent down here right now? Okay. So do you agree from this angle opposite is 5? Mm-hmm. So if that's opposite, do you agree this is the longest side? The longest side is always the hypotenuse. There's only one side left. It has to be the adjacent. Yep, good question. Okay, here we go. Cosine is what? Turn to your partner, you have 5 seconds. What's cosine? What divided by what? What are the words?
Adjacent divided by hypotenuse.
Adjacent divided by hypotenuse. So adjacent is 4 square roots of 3 over the square root of 73. Go ahead, please. Tangent is opposite over adjacent. Opposite over adjacent. Okay, I'm going to give you 15 seconds to rewrite the ratios for what I call the secondary trig functions. And how you do it right now is just flip them. Just flip them. You ready? You have 15 seconds to go.
What do you do for the cosine?
So
Now that there's both.
we're going to do that in a little bit. Yeah, we're going to get to that. Square root of 73 over 5. Square root of 73 over 4 square roots of 3. 4 square roots of 3 over 5. Okay, Andy, thank you for allowing me to call on you. Please no talking. Andy, there are, if I want to think of these as answers, there are 5 answers, and only 4 of them right now are in proper form. Proper form means like they could be in the form that could say this is the final answer. Do you know which 2 of the 4, do you know, sorry, which 2 of the 6 are in proper form, Andy?
Tangent, cosine, and sine.
Okay, these, okay, and can you tell me why you think that?
Because a lot of them have square root at the bottom.
Okay, so that's a great point. We want to have an answer that has no square root on the bottom. So which ones have no square root at the bottom?
Most of them don't, but only cosine code on the other one.
Yep, so CSC is called cosecant. I'm going to circle it, please do the same. Cotangent, circle it. Now, why am I circling those? Because they have no square root on the bottom. They're already in proper form. Okay, are you ready? So here we go. How do I do sine? I'm going to go through this really slowly. I take this bottom and I throw it up to the top. So 5 square roots of 73, and then I write the number on the bottom with no square root, and I circle it. I would like you to skip over these 2 because we're going to do those together. Those are like bonus ones. They're a little more difficult. I would like you to do this one right now. You have 20 seconds to begin. This one right here, begin.
How would you do that?
We're going to do these together. Do this one right here.
Do you know how to do that? How to do it? Well, we probably.
So I only care about removing the square root, not the 4. That's not a problem. It's the square root we can't have in the denominator. So the square root gets thrown up top, and then I rewrite the bottom with no square root around it. So I have 5 square roots of 4 on top, on the bottom 4 times 3 is 12.
What did the 4 get a square root?
So what'd you say? Did I write something down wrong? I meant to say 3 here, didn't I? Thank you for finding that for me.
Wait, so it's supposed to stay 3?
It's supposed to say 3, and I don't know if I even said it wrong, but...
Because it has a square root.
So the square root of 3 gets thrown up top. I said it wrong. Square root of 3 gets thrown up top, and then I rewrite the 3 with no square root.
And that's 5.
5 square roots of 3 over 12. Okay, ready? Here we go. So I'm going to go through this one. You're going to watch me do the first, so put your pencil or pen down. I take this and I throw this up top. So it's 4 square roots of 3, square roots of 73, and then I write the 73 on the bottom. Now, when I look at these 3 different numbers at top, 4, square root of 3, and the square root of 73, only 2 of them are alike, 3 and 73. So we can multiply those together. 3 times 73. So this becomes 4 square roots of 219 over 73. I would now like you to use this concept to rewrite the secant. Ready, get set, and begin. You have 30 seconds on paper.
How did you get 219?
Because when I looked at these 3 terms, 3 and 73 both had a square root. That means I can combine them by multiplying. So 3 times 73 is 219. So the 3 down here gets thrown up top. And I'm going to write it down here because I have a little more space. So I'm going to write this as the 3 gets thrown up top, and then I rewrite the 3 in the bottom with no square root. Now, I just showed you on the calculator that 73 times 3, they're in the same form, square roots, can be multiplied to equal 219 over 12.